Hey mathletes, here we are looking at our inequalities in triangles. So our goal today is to be able to order sides and angles of triangles using properties and theorems. Okay, so our first theorem here is our triangle longer side angle theorem and our triangle larger angle theorem. So what I'm going to do is use a little GeoGebra to have a better sense of what these theorems are saying. So you just go ahead and create a triangle. Okay, and what I'm going to do is I'm going to go ahead and measure all my angles and then measure my sides. Okay, so what we'll notice about any triangle is that if we identify our largest angle, so our largest angle here is 87.2, that opposite our largest angle is our largest side, 11.3. I look for my smallest angle, 34.7. Opposite of that is my shortest side, 6.4. So our theorems here is stating that. So if one side of the triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So here we see 5 is smaller, BC, than AB8. So that means that angle A is going to be smaller than angle C. Okay, or angle C is greater than angle A. Okay, and then we can do that also if we're given angles, we can determine things about sides. So if angle A is greater than angle C, so the side opposite that, BC, is going to be larger than angle AB. Okay, our third theorem here is our triangle inequality theorem. So if we think about this is just saying that the two other sides of a triangle must be greater than the third side. Okay, so if you think about this, right, the reason that why this has to exist is because if by chance we look at these different sides, okay, so I take that and I rotate them and get them all linear. Well, it's not a very good line, but it will work. Okay, at the very most, if we have that angle between here, that third side has to be shorter than those two sides. If it was to be too long, okay, then there's no way that we can make a triangle out of those sides, because even at the most extreme angles, okay, we're not going to connect in order to make these triangles true. So that's what the triangle inequality states, that any two sides of a triangle have to be greater than that third side. So notice we just rearrange it, and these are all the different options that blue, red blue is greater than green, green blue is greater than red, and red green is greater than blue, and we're just doing the different combinations that are possible. So notice we have green on one side, red on the one side, and blue on the other side. So all of those have to be true. Okay, so as we apply these, okay, if we're given our side lengths and we want to order the angles from smallest to largest, I'm going to look first for the smallest side. So my smallest side is 6, so therefore my smallest angle is angle C. Okay, so then my next largest side is angle 8, so opposite of that is angle A, so that is the next largest side. And my largest side is 10, so opposite of that is angle B, so that'll be my largest angle. Okay, for 7, similar idea, smallest to largest, so look for smallest side. So therefore, smallest angle is angle D. Okay, next largest side is 15, so opposite that is angle E. So that's going to be bigger than D, but smaller than angle F, which is opposite our largest side, so it must be our largest angle, F there. Okay. Similarly, smallest side, angle H. Next largest, opposite, angle J. And so by default, we must have angle G. And that's true because it's opposite our largest side length. Okay. These next examples, what we're trying to do is if it's possible to construct this triangle with these given side lengths. So what I want to do is set up my three inequalities. So if I do 3 plus 12, is that greater than 17? Well, that's false, right? So right away, my first inequality is false, so it's not possible. Okay, you only need one to fail to determine if it's not possible for our side lengths. Okay, notice if we did continued or we did a different order, we would see that, okay, 12 plus 3 is greater than 17, which is true. And we can see that 12 plus 17 is greater than 3, and that's true. But just because we got one false statement, we know it's not possible for a triangle. Okay, for number 10, again, 5 plus 21, is that greater than 16? Sure is. Is 5 plus 16 greater than 21? Well, 5 plus 16 is 21, and 21 is not greater than itself, so it's false. So being false, it's not possible. Okay. Number 11, we have 8, 5, and 7, so 8 plus 5, is that greater than 7? Check. It is 7 plus 5 greater than 8? Check. So I know I need to have 5 here, so this is 7 plus 8. Is that greater than 5? It sure is, so it is possible. (17), 10 plus 3, greater than 11. 11 plus 3, greater than 10. And 10 plus 11, greater than 3. Those are all true statements. So therefore, again, we have a possible set of sides of our triangle being 10, 3, and 11. Okay. Final question here is a triangle has two sides with lengths 5 and 13. Describe the possible lengths of the third side of this triangle. So I'm just going to let x equal my third side, potential third side. Okay, so again, I can set up my inequalities and say, okay, 5 plus x has to be greater than 13. I'm also going to have 13 plus x has to be greater than 5. And I also need to make sure that 5 plus 13 is greater than x. So now with these inequalities, we want to simplify them. So if I subtract 5 here, subtract 5 here, I get x must be greater than 8. Subtract 13 here, subtract 13 there, I get x is greater than negative 8. And here, add those together, I get 18. So 18 is greater than x. Or I can write it as x is less than 18 to try and look at all these. So if we think about this as a number line, okay, our solutions are going to come from where they're all overlapping. So if I graph these, I'm going to highlight some key points here. So I have negative 8, 8, and 18. So I'm just going to think, it doesn't need to necessarily be equally spaced out, but there's 0, negative 8, throw in 0 there, 8, and 18. Okay, so this is our number line for x. So x being greater than 8, okay, at 8, it's an open circle, and it's shaded all the way to the right of values greater than 8. Okay, x greater than negative 8, do that in blue. So negative 8, x is greater than that are here. So we see some overlap there. And then our last one is x is less than 18. Well, x is less than 18 is over this way. Okay, so what we identify here is here's our solution set where everything is possible for all of our x's. It has to meet all three conditions. Okay, so that's we can tell by the shading there. So we can say that x has to be greater than 8. It's non-inclusive because it's an open circle, and it has to be less than 18. Okay, so those x values would satisfy all three of our conditions to make sure it can make a triangle. Okay, this concludes our notes for today. Please bring any questions to class.